Hi, my name is Susan Bastian from the University of Toledo, and the title of my project is Arctic Sea Ice and Air Temperatures. This project was done in conjunction with the LEADERS Grant Program, a National Science Foundation funded grant program conducted at the University of Toledo. This particular class is on Earth technologies and was jointly taught by Dr. Kevin Sikowski, Dr. Michael Lynn Headley, and Dr. Donald Spearman. The purpose of this project was to determine if the Arctic sea ice levels could in fact be correlated with air temperatures in Barrow, Alaska. I hope to actually prove that there's more than a correlation, but actually causation. In other words, that retreating Arctic sea ice levels are in fact contributing to warming air temperatures in Barrow, Alaska. My hypothesis is that the lower the extent of Arctic sea ice in September, the higher the mean temperatures are in October in Barrow, Alaska. This particular picture is a photo from the NASA MODIS satellite showing the proximity of Barrow to the Arctic ice sheet. To conduct this study, I first looked at the October air temperatures for Barrow, Alaska from 1979 to 2009. I chose this time period because the earliest satellite images of the Arctic ice sheet start in 1979. There is also extensive weather data available for Barrow, Alaska. I was able to obtain mean monthly air temperatures for this site from weatherunderground.com. September sea ice was examined because that is the month in which the sea ice reaches its minimum level. The exact date varies from year to year, but is always in September. To help determine causation, I wanted to look at the air temperatures in the months following the month that the ice was at its lowest levels. That is why October air temperatures were measured and September ice levels were measured. The information on the September sea ice was obtained from a NOAA National Oceanic and Atmospheric Administration graph. I could not find the data extant and instead had to pull it from the graph and determine it that way. The ice is measured in a percentage of deviation from the average sea ice level from 1979 to 2000. This is because a more marked and rapid decrease has been seen in the sea ice levels since the year 2000. I then analyzed these two data points to look for trends. I also obtained satellite images to visually support the data. This is a satellite image of Barrow, Alaska from Google Earth imagery. The A marker is where Barrow is located in relation to the rest of Alaska. These images are courtesy of NASA's Visible Earth Image Catalog. The image on the left is the Arctic sea ice in 1979. These are composite data images. The picture on the right is from 2003 and the same information in the same place. As you can see, the sea ice has retreated dramatically. There's a huge change between 1979 and 2003. This is the graph from which I obtained my data on the sea ice extent. They actually track March and September, March being the greatest extent of sea ice, and September being the lowest. This is the results that I obtained. The y-axis shows the temperature in degrees Celsius, and the x-axis shows the percent of sea ice deviation from September sea ice averages from 79 to 2000. I applied a trend line and was able to obtain an R-squared value of 0.4254. As you can see, there was a more rapid decrease in the Arctic sea ice since the year 2000. During the same time period of 79 to 2009, the average air temperatures in October in Barrow have been increasing. The extent of the sea ice does not decrease in a regular pattern. In other words, every single year it is not less than the previous year. However, when analyzed over a 30-year span, definite trends can be seen, as was seen in the graph on the previous slide. This is a graph from the National Snow and Ice Data Center in Boulder, Colorado, showing the Arctic sea ice extent, again deviating from the 79 to 2000 averages, which is the gray shaded area. This graph takes it further past the data that was analyzed in my report, showing that the decline is not only continuing for sea ice, but also seems to be speeding up. So my data supported my hypothesis. There is a clear correlation between the extent of Arctic sea ice and air temperatures in Barrow, Alaska. Because the air temperatures were analyzed for the month following the month in which the sea ice reached its minimum extent, I believe causation can in fact be inferred. As the sea ice retreats further each year, the land along the edge of the sea ice is directly affected. Warmer temperatures allow the permafrost to thaw, which can adversely affect existing ecosystems as well as human structures and roads. Further study of other locations near the Arctic Sea is strongly recommended to strengthen the findings of this study. The study was extremely limited in scope. I would also suggest analyzing average monthly temperatures for more months beyond just October, looking to determine if the effect of the receding sea ice has a greater impact than just the following month. I would like to thank the following people for their guidance and support during this project: Dr. Kevin Sikowski, Dr. Donald Stearman, Dr. Michael Headley, Grant Wilson, the Leaders Program, and the University of Toledo. Thank you very much.